Hey everyone, welcome to Devshop. We're gonna get started now, and I'm really excited to introduce our featured talk tonight. We have a bunch of you signed up to give project demos and lightning talks as well, so really looking forward to that. If you're joining us online, please click the live button to sync up with a live stream from Meteor HQ. You can submit questions for our speakers by submitting them using #Devshop on Twitter. If you're in the room here with me now, then please take this opportunity to silence any cell phones or devices that you may have with you now. All right. So our speaker tonight is Slava Kim, one of the core developers here at Meteor. I know a lot of you know Slava online. He's super active in the community. We really love him for that. Here at Meteor, Slava was a big part of the Windows support that we just released with 1.1. He's also done a lot of work on mobile, Mongo uplog tailing, and Blaze features. He has a really interesting talk prepared for you today that I think will really teach you a lot about the fundamentals of how Meteor works. Specifically, what does it mean to be a real-time database, and what functionality has to exist for it to integrate with a modern application architecture like it does in Meteor. So everyone, let's welcome Slava.
I'll just prepare my notes. Hey, everyone. So today's talk is going to be a little bit educational. It's not going to be very exciting with announcements and all of that, but I still think you'll benefit from it just by learning how Meteor architecture was designed and how it works in general and what does this modern web application architecture expects from the data store that you might use. And I think this talk is not really specific to Meteor. It's just an explanation how Meteor does it, but you can as well implement it in your own stack if you want to. So the talk is called, what does it mean to be a real-time database? And I guess the answer is obvious, like it needs to be a database, it stores data, and it should be real-time, it should give me notifications. But we'll look into more details, how Meteor uses different databases or might use, and why it is so important. So as you know, Meteor is an SDK that contains a lot of different functionality and features. And this picture, I've been using this picture in many, many slide decks. The basic architecture is you have a server side with an access to the database, and somehow you see the changes there. Also on the client side, you have a cache. In our case, it's mini Mongo, but it could be something else. And this cache is driving all the UI changes on the client. And between them, there is something called DDP. It's a protocol that defines how do you pass data around and how do you perform any actions from the client on the server. So Meteor is really a collection of packages and technologies, and it's not uncommon to see for us, like other people in the internet, take apart different parts and use it in their applications. Also, you can replace different parts. For example, Mongo could be replaced with some other database, and Blaze can be easily replaced with React or Angular, as you might have seen before. But there's something very core to Meteor that it's not really easy to replace, and actually you shouldn't, because it's in the core of the functionality of Meteor. And I'm talking about the protocol, DDP, and everything is just structured around it. So DDP is a protocol, is just a definition how data should be passed around and how method calls should be performed from client to server. So it's not a magical implementation, but it's just in design how the architecture should look like. And particularly, it helps us to implement this important feature called optimistic UI. So you might have heard other names in Meteor here. We often use client-side prediction or latency compensation. Also, there are other names like Death Reckoning. It's used in gaming to predict where your character will appear on the screen, even if you don't have enough time to communicate with your server. Like the simplest definition that I found was speculative mutations. The basic idea is when you modify something in your database, first you do it on the client so the UI can update immediately, and only then you go to the server and do it in the background. So for the user, when they use your application, everything appears to be really fast because all the changes are made locally. But also, the changes are validated on the server. So if the client tries to tries to do something sneaky, the server will invalidate all the operations and say, look, here's what actually it should be, and don't try to speculate too much. So this is a core feature of Meteor that I don't think we talked about enough, but it actually lies in the core of Meteor. So here they have an example of latency compensation in the application called WhatsApp. So it's a chat app owned by Facebook. And in this video, you can see the user is typing some message, hitting submit, and you can see there's a small clock that says it's not sent yet. And then it becomes a tick, meaning that it was sent and acknowledged by the server. So here's a perfect example of how latency compensation works. We insert the message immediately into the chat history, even though it didn't hit the server yet. And only then we update it to a tick. So I'll just show one more time. It becomes a tick after a second. So here's another example. It's a hackpad. It's a collaborative web app to collaborate on documents. And as you can see on the right side, I'm typing text, and it appears on the left side much slower with some latency, because I'm doing it over the internet. So on the right side, I can type letters. Everything works just like a local text editor. But on the left side, it actually appears with a delay. And this is another example how you can just perceive latency in a different way. For the user of hackpad, they don't even know which letter was synchronized, which was not. So if it was done in a traditional web way, I would wait for every letter to be synchronized with the server, and I would need to wait before I type any next letter, which would be ridiculous for a text editor. So latency compensation is a complex topic that tries to help you achieve good user experience. And recently, we have released a blog post. One of my coworkers called Sashko Stubailo wrote a blog post on our Meteor blog. And he has a written down explanation how it works with diagrams, and you can see it online if you want to later. So today, I'm going to focus on how you would implement that, or like how it is implemented in Meteor. And my claim is it is really hard to implement yourself without a very well thought out architecture that Meteor already provides. And just as an example, I want to show you the website called Instagram.com. I don't know, maybe you know it. But they have a web version of it where you can see pictures and comments. And I just want to show you how latency compensation can break even in a very successful web app. So let me type some comment here. I'll press enter. It will appear and disappear. I don't know why it happens, but if I refresh the page, I see it's still here. So let's try again. I'll type some comment, press enter. It disappears. I don't know why. I think it's a bug, but that's just a demo for you guys. It is hard. It can be hard. And Meteor tries to make it easier. So again, here's a general architecture. It's exactly the same picture. And I want to walk you through how a client would make a modification to the database from the browser to the server and back. So imagine we're building a chat app just like WhatsApp, because everyone knows chat apps are the most valuable apps out there. It's not Instagram anymore. But if you can see how it usually happens. Usually, it starts with a user action. And here, actually, we're focusing on the data layer. That's why I will dim out the front-end part, because it can be anything else. So it starts with the front-end layer getting a user interaction. A typical user interaction would be pressing a button like submit this message or like create this chat message. This code runs a JavaScript function that would be executed in Meteor on both client and server. This is what we call RPC, remote procedure call. And in Meteor, RPCs are simulated on the client to achieve this latency compensation, this fast result. So on the bottom right, I have an example, a pseudocode, how my RPC would look like. It would be something like, oh, if this in the simulation, then add a message and set a flag called is in flight to true. Otherwise, on the server or not inside the simulation, just add a message. So here, I set a special flag in flight, and I do it for a specific reason. I want to distinguish documents that have been synced already with the database and documents that have not been synced. So remember that clock in WhatsApp? That's what I'm doing. I'm trying to check if I should show a clock or a tick mark. So I press the button, I run the RPC on the client and on the server. What happens next? The client is changed immediately. It's driving the updates in the UI. So the simulated changes appear immediately. So later, after 300 milliseconds on my server in Arizona, I will get the result propagated to the database. So it will be in the real database, and my database will emit a notification, hey, this document has changed. So Meteor server would notice it and propagate this update to the client over DDP from the server. So you can see the propagate updates. And after it propagated all the updates, it will send me a special message in DDP called update, or updated. I think there is a typo here. But the general idea is the message updated means, hey, look, client, you've done some changes in RPC, and I already propagated all the changes in the database to you. So you can be sure that the state I'm presenting you is exactly what it should be after the RPC is done. So the client understands that it synchronized the state with the server, and it can throw away all the simulations that it have done before. So what will happen, it will have a tick mark first, and then it will receive this message that says everything is ready, and it can throw away this tick mark, saying that, OK, I synchronized everything. I don't need to keep it around anymore. And then you show the actual change. So this is the basic idea. And this whole idea is possible because the protocol of communication between client and server supports it. So we have a DDP spec on GitHub, and it's just a definition what each message type means. And there's an interesting thing in DDP. It combines the relationship between data notification, or like notifications about data synchronization, and remote procedure calls. Something that you wouldn't normally mix together, but in this case, it makes total sense because we need this updated message. So later in the spec, you can see there's something about updated. It goes from server to client. And what it means like I propagated all the changes in data sync related to your method call. So this is powerful, and we'll just look how it's implemented in MongoDB with MongoDB right now in Meteor, and how it could be implemented with other databases like RethinkDB and PostgreSQL. So let's start with MongoDB. You probably have heard it many times. Meteor tails oplog. Oplog is a replication log of MongoDB. This is how databases replicate themselves in case of failure. And what Meteor does, it connects to MongoDB and looks at this endless stream of documents of changes. So every document that represents a change contains an ID, what document is changed, what fields are changed, but also it contains a timestamp. So every change is ordered. And at any given point of time, we can just figure out what is the latest timestamp in the oplog, in the replication log. And this is what helps us to actually understand when we can send this updated event to the client. So what happens, we start in RPC. As soon as every write is done, we try to remember the position in oplog. And then when our observers actually reach that position, we say, OK, we are sure that everything related to this RPC is already propagated to observers. And this is how it's implemented. And yeah, oplog is good because it has changes and timestamps. And now let's look at a different database. It's a database called RethinkDB. What RethinkDB is an open source database that works on documents. Similar to MongoDB, it doesn't have any transactions or joins. It has joins, actually. But it also lacks some other features like replication, which is really important for a database. I think this is why it didn't get much adoption yet. But what happened, we had a hack week here in Meteor. And hack week is a time when every core developer takes a week of time to implement any hacks they want. And it doesn't have to be the highest quality, but this is some experimentation time for us. So what happened, I decided to build an integration with RethinkDB and Meteor, just because I have heard that RethinkDB is advertising itself as a database for real-time web. And the reason they do that is they have implemented something called change feeds. And change feeds is essentially the notification stream for queries. When some query changes, like it just gives you an event, hey, this document changed for this query. So this was useful, and I thought, OK, let me implement it in my 1 week. And I got the proof of concept working with a demo. And I put it on GitHub. And even though it's not ready for production, people tried to use it and kind of failed. But I think I tell it very clearly in the README, it's not for production use yet. And I'll explain why. So what works with RethinkDB? By the end of my week, I figured out that queries, pops up, RPCs, all of that works. For the client-side cache, I used a repo called Equalite, which is a re-implementation of RethinkDB query in JavaScript. And I got all the client-side simulations working. So what didn't work really was latency compensation, the most important part of Meteor. And the reason for that is RethinkDB doesn't expose additional metadata. So remember oplog? We had timestamps. Like every change could be associated with some unique identifier. In RethinkDB, it doesn't happen anymore. Like every change just appears in the stream, and you can never know if your change has been propagated all the way through. So this is why I couldn't get the latency compensation to work, that magical updated message. Also, another thing that I found about RethinkDB, it doesn't support change feeds for complex queries like joins. Also, it doesn't support initial result set for most of the queries except for sorted queries. And Equalite. Unfortunately, I found out that this repo was created in the free time of its author, so it wasn't really the level of quality of mini Mongo that you would expect, like many queries will fail or there are typos in the source code. But I'm pretty sure it will improve in the future. And once RethinkDB exposes more metadata about their changes, it will be much, much easier to implement the support. So what about PostgreSQL, you might ask? So I've done some research. It's not written in code. It's not even written in design yet. But I found out that replication log in PostgreSQL is the same format as write-ahead logs that all the databases use for recovering from failures. Also, PostgreSQL provides a lot of useful functions to actually look inside of replication log and get all the positions and locations and identifiers, something that RethinkDB doesn't have, but we got from MongoDB oplog. So this is just an example like how one database, RethinkDB in this case, implements notifications, but they don't implement this additional metadata that Meteor might need. And PostgreSQL is the opposite. It doesn't implement the notifications. I mean, there are other ways to do that, but it actually is a very mature database, and it provides a lot of different functionality for all sorts of needs, including querying the replication log. So what is real-time database really? So if we skip the first 3 bullet points that it doesn't lose your data, like you can query your data, you get the notification with initial set results, and in the end of the day, you actually get the metadata with your revision numbers, because this is something you need to implement more complex features on top of real-time notifications. Just real-time notifications would not be enough in an architecture like Meteor, and I believe many other modern architectures where you would have latency compensation built in, and there would be one source of data, one source of truth, and everything would be working from one database, or like from one source. So this is it. This is my last slide. I hope you learned something about Meteor and how it works inside. And this was my small project in 1 week about RethinkDB and a small research how it would be done in other databases. Thank you.
Right. Does anyone have a question for Slava? Rahul.
So looking at the last slide,
Yeah.
You said skip the first 3 bullet points. The last bullet point to skip basically describes that there is a real-time database in existence that fulfills all of the requirements, but requires you to write your queries in Erlang.
Oh, I can explain. So I tried to make a joke. In the third bullet point, I tried to make a joke about one database that at some point of time required you to write queries in Erlang. But I don't think it does anymore. And I think it was just a big stone on adoption for the database. And no, it doesn't have any real-time features like notifications.
I was excited.
It's good to have a dream.
More questions? Yeah, in back.
Do you know if Rethink is planning on adding support for different types of queries change feeds?
The question was, do I know if RethinkDB have any plans for change feeds for other types of queries? So my understanding is something like join is just hard to implement incrementally for notification feeds, and I don't know if they have any plans for that. What I do know is they plan to include the initial result sets for more queries that they support. This is something that is not supported right now, and it's hard to deal with in the application layer because you don't have any control over concurrency there. So they want to do that in the next version 2.1, and I asked them about more metadata about the revision numbers on the changes, and they said that they might consider that if enough people will ask for it on their GitHub tracker. So if you guys want, you can try and ask them, providing a use case, of course. But yeah, even if they don't, I think at some point, a lot of databases will expose most things like this because the use cases will require more and more control over what's going on inside.
We have a question from Eric Wine online. So he asks, do you plan on continuing to develop RethinkDB for Meteor?
So the question is, like, do I even plan to support it at all? And again, I'll repeat it. I developed it in my time dedicated to hacks, and I have a proof of concept working. And until every blocker is resolved, I'll just not be able to provide high quality support for that. So I will wait for a magical Christmas or Hanukkah when I get all the features I requested from RethinkDB team. And then I'll be more than happy to spend my Christmas holidays implementing it.
More questions from the room?
Thank you.
All right, thank you. All right, next up, we'll have lightning talks starting in a few minutes. You can see the lineup at lightning-talks.meteor.com. We're going to take a short break first, so if you're speaking, please come backstage now over here to my left, and Sam will help you get mic'd up. So everyone else, you can take a couple minutes to stretch your legs, and I'll see you at 7:25. right, we're starting lightning talks now. So first up, we have Harry Ward.
Hello. My name is Harry Ward, and I'm going to be running you through a pretty quick presentation on streamlining small-town business operations with Meteor applications. I'm going to cover how we found a problem, how we solved it, and then a couple quick demos. One that's totally not related, but it's kind of cool, and I hacked it together today, so I want to show you that. About me, I started as a salesman, then I became a developer, and for the last 4 years, I've been essentially scratching itches for the company I work for. I build internal operational tools that solve problems, and with Meteor, I can solve problems a lot faster. So the next part I want to cover is I knew I wanted to build an application with Meteor because I learned it, I was playing with it, and you can only play around so long until you actually want to put your work to use. So, but I didn't know what to build. So I went back to my hometown, Missoula, Montana, and I decided to start talking to people and see if there's any itches that I could scratch. I ended up having dinner with my girlfriend and Scott Anderson. He's the middle guy in the boat, and he was telling me about all these operational problems that fly fishing outfitters have in the state of Montana. And they're primarily wrapped around scheduling and reporting for fishing outfitters. The first problem, which is kind of a big one, is the guide scheduling. You have a customer, which is on the left-hand side, and then you have an outfitter. The outfitter is like the travel agent for the guide. So a guide can't get a fishing trip directly from a customer. They have to go through an outfitter. So the outfitter is just kind of sitting there and calling all these guys or text messaging all these guys. I only put 6 on there. Some of our outfitters now have 20 guides in their pool. So they have a customer that calls up. They're literally making 20 phone calls. So that's a huge problem. Eventually, they select one. Then they match that guide up with that customer. The outfitter doesn't go fishing at all. All they are is a middleman. So the fishing trip happens, and then the final product of that is a trip log. The trip log contains information that the state needs about the fishing trip because they require all these crazy reports on fishing. So in this case, a single fishing trip has to be reported to 4 different entities and not the same report. Okay, same data, but different reports. So what these guys had to do, and keep in mind, these guys aren't computer geniuses, they live in log cabins, and half of our clients barely have internet. So they're having to sit there and either do it by hand or use Microsoft Excel and copy and paste about 400 times. We have clients that the fishing season started about 2 months ago, and we have clients that already have 300 trips on the books. So we created this solution called GuidePool, and it's $29 a month for outfitters, and it's free for guides. And we had 3 guys, so with 3 guys, we were able to launch this app. I don't consider myself a rock star developer, or at least I didn't then, but I was able to put together an application that's producing revenue. And it feels pretty good. And now I have RJ, who's tuning in, I want to say hi to him, and Jason Cross, who are making phone calls about 15 hours a day to outfitters selling this application. So I just want to cover the achievements really quick. So in 2 weeks, we had our first paying customer, and in 2 months later, it's been 2 months, we have over 50 paying customers and almost 300 members. And this is GuidePool. So I'm just going to cover the 2 problems. Number 1, booking a guide. So each outfitter has a fixed number of people that are in their pool. So this is my direct team, all my guides, and they all have calendars and everything. And if I want to book a trip on the 23rd of July, I only see who's available on that day. I just saved myself 20 phone calls. Okay? So once a trip happens, yep, I'll wrap up soon. Once a trip happens, we have a fishing trip landing ticket that they fill out, which populates all of these reports, which repurposes all this data into a bunch of different report styles, which is accepted by the state. And that's the reporting side of it. And the last thing I wanted to show you is this shows you, based on where you are, the parking or the street cleaning schedule. And I built this today.
Nice. Cool, thank you.
Yep.
All right, next up we have Clarence Liu, and he's going to show us Live Audit, which is a paired mobile app as a tool in Meteor.
Cool. So hi, I'm from Intelligent Dealer. We're backed by NCM Associates. We're not a startup. We've been around for a very long time. We're in about 7,000 dealerships across the country. Accessa, which is our previous product, I was a lead of for 2 years. We have 700 plus clients now. And we basically integrate their accounting systems and pull pretty much all their data and do financial reporting. So we're looking at Meteor for our next product and hopefully to rewrite our main product, Accessa. I just want to show you a couple cool things. Obviously, we have our expenses. We pull all their checks. We can do total up their expenses, let them put limits on their monthly expenses per vendor so they can know if they go over or not. And trust me, these dealerships, they're pretty much in the Stone Age, so they don't even have basic things like that. Our three main core features are the tracking of the transactions, expense summaries, and we have a system for contracts and invoices, and that's what I want to show you of a paired mobile app. Basically, one of the business use case scenario that we had was that clerks just needed a way to get their invoices approved by their managers, and the way they do it now, and ABC Mercedes, that's actually San Francisco Mercedes down the street right here. They literally staple the receipts with their invoices, put in a box, hope the manager comes by sometime and approves them all. So what we did is, this is a special use case scenario. They actually had security issues. They don't want clerks going off of a login. So what I have here is a mobile app that just uses a pairing code. So what we do is we generate a unique pairing code. We store the unique device ID on in local storage. Pair it together. Automatically, the phone picks it up. You got 2 dealers here. You can definitely look at your reports. You can't see this, but just basically what you're seeing there. It's a simplified report. But the cool thing is, with the reactivity, I'm able to scan an invoice directly from my phone and put it up there. So this is kind of an extension of your tool. So if I were to go into, let's see what I recognize here. List this dealer here. And okay, maybe April's bit over. What happened in April? They're talking down here. You can obviously talk about it and shoot a message. But obviously, somewhere along the way, the manager's going to say, "Hey, can you scan that invoice?" And then we can just go down here. When I click scan on mobile, automatically the app picks it up because basically the application. We just basically, in the router's action method, always watch a state variable in Mongo DB. So it's shared between the web app and the phone. So automatically it picks it up. Hey, you're looking at Maverick document signing. Just confirm, is that who you are? Picks up information. I press scan. Camera app pops up. Everyone try to pose like an invoice. One page. I can do multiple pages. I hit submit. Boom, it's up there, so you can see it right here. That's you guys. And definitely down the road, we're shooting for a 90-day beta release. We definitely want to get some OCR going. So talk to this guy here, awesome Amazon simple workflow, maybe even throwing that in there. We're looking at microservices. I just last week in Park City, we just opened an office in Park City with a team of Meteor developers. And over in Park City, we're at a Docker meeting. We just got our Meteor app Dockerized, so looking at microservices, all the processing in the backend, especially with all the checks that come through. We get thousands of checks a week per dealer, and you're talking about 700 dealers. Basically, it's a lot of workflow, basically. So simple workflow is awesome, but microservices is what we're looking at now. That'd be really cool, where we have lots of Dockerized microservices processing the queue. And that's it. We're shooting for 90 days, and I guess the car dealership industry is kind of, no one knows about it, but there's no competition there, and we're getting more advanced. Any questions?
All right, thanks a lot.
Okay.
All right, next up we have Brian Renero. He's from Mongo DB, and he's going to give a talk called 5 Aggregations in 5 Minutes, a nickel tour of the aggregation framework.
Or less. Less than 5 minutes, but the same number of aggregations. I have to get my aggregation to minute density up. Quick thing here. So I am Brian. I am a developer advocate at MongoDB. I've been there long enough to secure the email Brian with a Y. No last name necessary. It's just there's not very many Brians with Ys out there. But feel free to ping me anytime. So we're going to talk about the aggregation framework in 5 minutes, and the basics with the aggregation framework. All you really need to know or understand is the concept of the pipeline. The way that the aggregation framework works, for those of you who are new to it, is that just like we might construct an operation on the Linux command line by piping together a set of operations where the output of the first one is piped into the input of the next one and subsequent down the line, the aggregation framework, yeah, I've learned how to do animations in PowerPoint, so I'm really proud of myself on this one, so I keep forgetting that I put that in there. In the same idea, we are going to build out an aggregation task by pipelining operators together and then sending data through that pipeline. In this case, it's a stream of individual documents from a collection being sent through these operations in the pipeline out to a resultant document or set of documents. A quick thing I should describe is that the aggregation framework is for doing things, basic reporting and some analytics, okay? So aggregate operations, and it's designed to be very, very easy to use and performant. One of the things that makes it easy to use is doing the operations are self-describing for the most part. Probably the most exotic thing that you will see here, oatmeal type exotic, is unwind, which is basically a looping operation on arrays. So what else do we have here? Let's go over here. That's about as sexy as the presentation is going to be. And I lost my display here. Where did you go? Exit full screen. And maybe we'll get it back. No, we won't. That sucks. So I'll use hand gestures. Maybe there will be 0. Let's see here. 0 aggregations. What happened in here? No, it was working earlier. It just may have lost it. That's okay. We'll go to just, maybe that's where I put it. Sorry. There we go. So this is going to be, if anybody thinks Markdown is sexy, here you go. I'll have to pull this back out, but for some reason, thank you, Markdown. Lost my presentation. First one. So what we're going to be doing here is that we're going to do a simple projection. That's going to be this guy right here. The project operator, oh, damn, it's still not there. Let's try that again. All right. So you'll have to believe me that there is something called the aggregation framework, and I did do a lightning talk. And the notion here is that we're going to construct each of these operators that are represented as JSON documents. So the first one's going to be a simple projection. Given a basic schema, here is the first document from the schema. I've created a sample set of just sensor data. In this case, there's a value for it, but it's associated with sensor data that would be pressure, temperature, humidity, that kind of thing. Random data set to construct against this. I want to project a subset of the fields on this document and to send it through the pipe. So here's my projection operator here. I pass it in as an object into the aggregate method, and here is the result set, just a projection of 2 fields from the original document that I had. Second projection, or second aggregation, is grouping. I'm going to use the same projection method I did before, and I'm going to add onto the pipeline a new grouping operation. This time I'm going to group by the device identifier, and I'm going to use the averaging method here to average the value of this sensor. So I'll get an average per sensor from the collection of documents that I've got. Number 3, add to set. Add to set is to, if I encounter a value, I want to add it to an array, right? And it's essentially getting distinct values from a set of documents and pumping them into an array. Here I'm going to project out the type of sensor, whether it's humidity, temperature, or whatnot, and I'm going to use the add to set operator here, and the result is I get this distinct set of types of sensors. And then finally, for 4, I can match by geolocation. These sensors send in where they are taking their sensor data at the moment that they take their sample. So if I wanted to aggregate and do an average on sensor readings based on a geolocation, well, golly, I can do that here. I use the geomatch operator here, and it's formatted in GeoJSON. Send it into the database, into the aggregation, and bingo. There's a lot too much to show here, actually. The results are kind of ugly. Much like the presenter. So the output to collection is the final thing. Is by default, it's going to just output it to standard out to the shell prompt. But I can write back to a collection. So the results that I've aggregated, I can put it back into a collection for use later, and it stays fresh for months. And just in case you don't think that aggregations are very sophisticated pieces of mathematics or operations, here's one that I like to pull out to show everybody how smart I am. This is calculating the variance of sensor data. So of course variance, then you square it, it becomes the standard deviation. So you can get some interesting stuff from it. Fun fact, whenever people see this, and there will be a quiz later if you want to memorize that aggregation task, this looks kind of wild, this syntax for building an aggregation. The reason that it does is it's a JSON representation of an abstract syntax tree. Anybody know what an abstract syntax tree is? Anybody care what an abstract? Yes. High-level languages are compiled into abstract syntax trees before the final mode of where they go into a decal tree, and then they'll be compiled into binaries. The person who originally designed the aggregation framework used the JSON tree structure format to represent an abstract syntax tree. So you can do lots of fun things. It's ultimately extensible as a high-level language would be. And I think I've exhausted all my time. So thanks.
All right. Next up, we have Tim Brandon. He's here from Gothenburg. And he's here to show us Space Talk, an app that he's been working on for 2 weeks now? Okay.
Yeah. Okay, first we have a problem. Here we go. So Space Talk, thanks for the awesome presentation, Alice. Space Talk is basically an open source chat application, which started out as a workshop material I created over a weekend for 2 weeks ago, which we used as material to build our own little chat application, Slack style. So this was the material I posted, and everybody had super fun toying with this, going through all the slides and trying all the exercises here. And after the workshop, I thought, why not put it up online and see who wants to work on this? So I posted it on forums and on creator.io, and it went haywire. So a lot of people started to join the discussion, and we started to vote on a name, and the name we came up with was Space Talk, which is kind of fun. So this is what the last slide in the presentation for the workshop was. So it's a simple Slack clone. So it doesn't have a lot of features. It just looks a lot like Slack. So that's all I did. That was around 1,000 lines of code in 2 days, actually. And then a lot of people worked on it, and it's 30,000, 40,000 lines more code. Let me log in and see how it works. So it's improved Slack. Let's see who's here. We have Arunuda. We have a lot of people. And I'm so impressed that so many people have added features to this thing, just like this. Yeah. And just recently today, we added smileys, which is, I mean, the Meteor community is amazing. That's the thing I wanted to say. But this is also the first release of Space Talk, and you're welcome to try it out and join the discussion and add features. We have a great roadmap in front of us, and I'm really looking forward to see what more we can do with this. I can show you some more features if you want to. So basically, it just looks a lot like Slack right now, which is something we will move away from. One thing I would like to add is that the learning outcome of creating open source apps is that you can own your own data instead. Excuse this. But basically that's it. Thanks.
Awesome. Does anyone have questions for Tim? We have a comment online saying it was so great watching this thing explode the last week. It's been a blast. Yeah, anyone from the room have a question for Tim?
Nobody's been asked. Why do you think it caught on with everybody so much? It seems to it took off like very quickly, and there's a lot of people contributing.
Could you repeat the question?
Yeah. Why do you think it took off so quickly? So I think there's a lot of people who want to work on open source apps, and also it's because there's tons of benefits of doing that. You learn how others code, you gain experience of new packages and ways to build your code, and also this is an application that will free yourself from letting your data be owned by a big corporation. So there's tons of benefits. I think that's kind of the core part why so many caught onto it.
And also, I guess you're using FlowRouter, media components, a whole bunch of new packages. Can you talk about that at all?
Yes, it's FlowRouter right now. It started out being our router, but some guys spent the night and implemented FlowRouter. So it's not my benefit, but it's FlowRouter. Thanks.
All right, thank you. All right, next up we have Michael Hackstein. He's a JavaScript developer at RethinkDB, and he's going to tell us about RethinkDB.
A bit more. So, good evening. I hope this works in a second. Yeah. So my talk will be about an introduction to the multi-model NoSQL databases. And I will start it with a short introduction to the other NoSQL databases that are out there. So document stores, you might know it's Mongo DB. You're using that with Meteor every day. But there are also other things like graph databases. You might know Neo4j, which can store relations between objects that you store and query along these relations really, really fast. And another thing is key value stores, which are rather simple and can just store opaque values to keys, but they are really fast and easily scalable. And these are the three major players in the NoSQL world. Now, let's bring some use cases to them. For document store, we could, for example, store products and users. They are really well fit for that. In a graph store, we can store recommendations, because there we have to connect the people that buy things and the things we have. And a key value store is really good for shopping carts, because we only want to access that by the session ID. And probably you guess where this goes to. We're building an e-commerce system. And to build an e-commerce system, and we want to use polyglot persistence, that means we use the best database for the job. We need 3 different kinds of databases to use this. And now comes the idea of a multi-model database. Multi-model database does not separate these data models, but it puts them all together into one technology and allows you to actually store JSON documents, key value pairs, and interconnect everything together in a graph. And that means for an e-commerce system, we can just use one multi-model database to use it as the back end. So what are the requirements for the database in this special case? A database has to be able to perform joins. It has to be able to perform ACID transactions, because otherwise you would be in trouble with graphs. In a graph, if you delete a vertex, you have to delete all the edges as well. If that is only done with eventual consistency, we are getting into trouble. And also you need a uniform query language on top of that that combines all these worlds. Now let's give you some example for this query language. A rather simple one. We're just iterating over all the products and returning them. Maybe we want to use a second level index and we want to filter them. So for example, we search only for yellow products, limit the result to 10. And now comes the cool part, we're adding graph features. So we now try, starting from customer, name Alice, and go to the product that we have thus just searched, and then define a new object, which is a join, formed by the product and the distance we have just computed. Then we continue with document queries. We can sort everything by the distance between the product that we buy and the person. Now let me explain the distance. Distance, if Alice has bought something, it is distance 1 because there's a direct relation. If a friend of Alice has bought something, it's distance 2. Friend of friend, distance 3, and so on. So if we are sorting it by distance, we will first find the things that Alice has bought, then the things friends has bought, friends of friends, and so on. So probably we do not want to buy the things that Alice owns already again. Therefore, we just use distance greater than 1. So what are the benefits if you're using a multi-model database compared to a single model database? You do not have a data model login. That means if you start with a document store and suddenly you think, I better need a graph database now, you're typically in trouble. With multi-model database, you can just switch under the hood. That allows for more flexible queries and reduces the client-side implementations because you do not have to implement joins yourself. And good benefit is you do not have to do data syncing on your application level. This is done by the database itself because it just has one data source underneath. And why am I telling you this? Because there's work in progress. RethinkDB is working on an integration to Meteor to bring you all these benefits of multimodal databases in Meteor as well. And that's it. Thank you very much.
Does anyone have questions for Michael? All right, thank you.
I think there's a question.
Oh, there is a question.
Do you have something equivalent to .log, or do you have a polling graph?
We are having the write-ahead log, similar to Postgres, and we are working on it to expose it in some similar format or something comparable to the oplog, so that we can integrate it into Meteor.
Yeah. And could you repeat the question real quick for the?
Okay, so the question is if we have something like the MongoDB's oplog already implemented, and the answer is we are working on something, and we are having the write-ahead log giving us all the necessary toolkit that we need internally.
Awesome. Any other questions?
No, thank you very much.
Thank you. All right, next up we have John Furneaux, and he's a collaborative tool specialist at Hive, and will tell us about Hive.
Presenter shift left.
Okay, hey guys, my name's John Furneaux, working at Hive, and I'm going to share with you the project that's going to bring Meteor to every office in America. So I am a collaboration nerd. I spent 4 years working at Capgemini, bringing collaboration to big companies like Shell Oil, UK Department of Education, big those sorts of organizations. And more recently, I've worked at Huddle.com, bringing Huddle, which is a collaborative tool, very successful, to places like Beats by Dre, KPMG, and NASA. That's gone off. Is it still going to work? There we go. What have I learned? I've learned that teams can think they're very fancy, but ultimately what they need boils down to three very, very simple things. The three things they need are, one, actions. They need to know what to do. Number two, messages. They need to speak to each other. And three, they need files. They need context for what they're doing, and they need to store what they've done afterwards. And it's always the same, no matter who you speak to. So why do we make people use three tools? If you look at a best-in-class stack now, let's assume they're not still on email and share drive. They're using something like Asana for their tasks, something like Slack if they're really forward-thinking for their messages, and something like Box or Google Drive for their files. I don't think that's a very good situation to be in. Why do you have to do that when in your personal life you have something like Facebook for all your social interactions, your files, your messages, your everything? So here they are, all on one page. I realize that's slightly fuzzy. I hope you can see it well enough. On the left, you have actions, the Asana part. In the center, you have messaging, the Slack part. On the right, you have files, like the Box part or the Google Drive part. Now, this may seem like a very cosmetic kind of change, right? Does it really matter? Aren't we good enough having integrations? Well, let's look at what happens to real user journeys when you swap them from the best in. So on the left-hand side, we have our actions panel. I write out the action. But because in the middle, I already have my messaging panel with all my team members in it, I just drop it into the team, right? And it's created the three actions for the three people. So what was a fairly annoying operation for something I do every single week becomes a lot easier. Now let's try Hive against a simple Slack operation, right? So I want to upload a file into Slack to share it with somebody, something with Jessica. I go find it. Of course, I might have an integration, right? But I'm still going to go hunt through Google Drive or through Box to find my file. Now let's see, it's still going. So I've got the next dialog, and I upload it, and I've got to wait for it to upload, and then it's finally shared. Now let's see how it works in Hive. Well, all my files are synced to my desktop through Hive Drive, which keeps a local copy synced all the time with the web copy. It's done already. I didn't have time to show you. All I'm doing is dragging right into my conversation with Jessica because the two are in the same page. There is no integration there. Both UI elements trust each other. So what are we doing with Hive? We're going for AngelPad 2015. Love to join some illustrious alumni like Postmates Criticism, Drone Deploy. Have some very difficult challenges ahead of us. Everything you've seen on the wall works perfectly, but I always worry about things like world-class security, how you do a really good job of file storage in Amazon, for example, and then search. Slack has shown us quite how important search is. We're going to be pushing Meteor to its absolute limits. If you think about Slack's meteoric growth, you can see the dangers of really fast scaling. And of course, the ambition is to be someone like Box, who did their IPO earlier this year. Thank you very much indeed for listening to me. I hope that made sense. Any questions from people? No?
So this was built with Meteor?
Everything's Meteor, yeah.
That's awesome.
Cool. Thank you very much, guys.
Oh, did you have a question? Okay. All right. Next up, we have Michelle Floyd. He's the founder at Cloakly, and he's going to tell us about using in-browser crypto to build a secure file exchange.
My whole presentation is on one screen. Slides, app, everything. No animation, though. So I'll let you guys read the right part. I won't belabor what's there, since you guys can read faster than I can talk. But basically, Cloakly is a secure end-to-end file exchange where all the crypto happens in the browser. All the PKI, the key management, happens in the browser. There's no secrets shared between the browser and the server. And you can upload files and encrypt them and share them with anyone else, any other member of Cloakly. The site is live. You can sign up for the beta at HTTPS Cloakly. And I'll just show you briefly how it works here. So what I've got is I've got two versions of myself. And I'm going to go find my other one and bring him up. And so on the right, I got one user. On the left, I got another user. And let me just bring a bunch of files over here and drag them into there. And what we'll see is that these files are actually being encrypted in the client at, in this case, wireless speed. And are moving between the two users. This is actually live over S3, but you can see basically the pace of most of those bars filling are actually the uploads. The crypto's already happened by the time it gets there. So we have a bunch of files over there. We can do the other side and download them. So let's see, we got the secret volcano lair, we got the Death Star blueprints. Oh yeah, one of the questions that people ask me is, who's this targeted at? And it's targeted at people like Frank Underwood, but more specifically, members of all of these different kinds of companies. So the app is 100% built in Meteor. It uses quite a few libraries that have been, very powerful: Crypto.js, SJCL, Collection FS, and a few more, like 20 more. And that's about it. So, questions?
All right, questions from the audience.
Yes, sorry.
So the files, when they hit S3, are encrypted.
They're encrypted before they leave your browser. Then they're also going up over SSL, so they're encrypted twice.
And then only other users of the app who you give permission to
Right.
can decrypt it.
Right. So you actually, when I drag the file over from the one user to the other, and you see here I'm using the user as a folder metaphor, basically. They're synonymous. But as soon as I dropped it on that user, I went and looked at the public key of that other user and used that to encrypt the metadata and the symmetric key of the file. All right, so I use an AES encryption on the file body itself because asymmetric is too slow, and AES is quite fast even in JavaScript. And so the key and the metadata get bundled in. All this metadata that you see on the screen is encrypted in transit as well. So if I get a subpoena from the NSA, I can tell them they've got a bunch of encrypted bits, but I can't tell them what's in the file or what even the name of the file or the file type. I can tell them roughly what size the files are, but that's not even exactly. So it's very, what I can reveal even to myself is extremely limited. Yes?
Where are the private keys stored? Are they just stuck in the browser's local storage? Or?
So there's a keychain that you have for each user, basically, and it gets encrypted with your master password before it gets stored on the server. So that's also encrypted with AES. Whenever like when you log out, you're going to lose your keychain. All the key management, like key renewal, key expiration, key revocation, is all handled in JavaScript in the browser. So nothing ever goes to the server unless it's already encrypted.
Could you repeat the question real quick? For the
Oh, sorry.
where are the private
The
keys?
question was where are the private keys stored. So each user is the only the users are the only people who have access to their private keys. I have no keys to the system at all. The public keys are of course public, but for efficiency reasons, they're only you only get access to the public keys of the people you're connected to, right? So here's a bunch of people who are connected to me. I see their public keys, but there's no reason for me to have everyone else's public keys unless I connect with them.
Other questions?
All right, thanks for hosting tonight. That was
All
really
right, thank you. All right, last up we have Michael Betts. He's a developer at omari.io. He's giving us a talk called Making Bridges.
Oh, Ben? Okay. Test? Okay. Thanks, audio guy. Oh, it's on the other side?
Well, we have an adapter, so we can...
Oh, it's okay. It's HDMI. Kendrick Lamar is awesome. I listen to him all the time when I'm doing Meteor stuff. But he doesn't know the world's most popular language, JavaScript. And so, basically, what I did, and I'm Mike from Omari, which is like this cool, obscure web collective that's up and coming from Santa Cruz. We made a Meteor version, hip, sexy, something like even Kendrick would use, a JavaScript version of codingbat.com. And check it on out. Oh, it's all open source, by the way. And I'm looking for some help. Look at this problem. I know everybody in this room could probably solve it. But I know like the people at home, maybe not so much. But can anybody solve this one? The parameter weekday is true if it's a weekday, and the parameter vacation is true if we are on vacation. We sleep in if it's not a weekday, or we are on vacation. Return true if we sleep in. What would Kendrick do? Does anybody know? Obviously return something. I don't know. Weekday? Not a weekday? Okay. Let's run it. Oh! We got it right. Let's go to our little folder. Oh, we got it right. Pretty soon this is going to be super gamified, like Khan Academy. And like people that totally don't know programming are going to start getting into it. Because it's all about making bridges between the tech and the non-tech, combining it together. Oh, Mari.
Thank you.
Oh, and there's a style guide I wrote for if you do want to add problems. If you want to add Euler problems or coding bad problems or any problem.
Right. Does anyone have questions for Michael? I have one. How did you use Meteor in this project?
It's built in Meteor.
All right, awesome. Any other questions?
How was that the answer to the question?
Oh, how is that the answer to the question?
Why weekday vacation?
Are you questioning whether or not it's built in Meteor? Or what is your question?
Your trial question.
Oh, your example question, why was that the answer?
Oh, I mean, we can go back to it. It's like logic. I don't know, dude. Like, look at it. It's a little verbose. The parameter weekday is true if it is a weekday. The parameter vacation is true. Like, it's a little logic thing. So you return a Boolean. Yeah.
All right. All right, last call for questions. All right, thank you very much. All right. So I have a couple questions that came in online for Lightning Talk speakers, if you're willing to answer them. I can just repeat your answers. So someone had a question for John about the pricing of Hive and what, if anything, you can share about the pricing.
Can you hear me okay now? What ain't broke shouldn't be fixed. Slack has shown a very good way to achieve both virality and good monetization. So I would start with exactly the same thing they had, which is free for everybody, and then $8 a month for admin features. So things like Google Sign-In, SSO, the things that just have to be used by bigger businesses.
All right, thank you. And then we had a question for Michael. Michael Hackstein. I know we had a lot of Michaels today. So, and they want to know how could people help with an ArrangoDB integration?
How could people help with an ArrangoDB integration? Yeah, actually just start developing it. So we are working together with one of you guys from Meteor and just get in contact with us, and then we can just discuss the details there. So we are looking for developers to do this. Would be really happy to get one.
So they should just reach out to you?
Yes, that would be best.
Okay.
Thanks.
Great. All right. Thanks so much, everyone, for joining us today. Thank you so much to our Lightning Talk speakers and to Slava. If you're watching online, please subscribe to be notified of new videos and Devshop live events. And in fact, if you're not watching online, you're watching here, you should still do that. We also upload videos from our London version of this event every month. So even if you come to all of our events here, you should still subscribe to see their videos because they're really awesome. Yeah, so our next Devshop San Francisco is Thursday, June 25th. We'll be announcing speakers for that soon. So please RSVP on meetup.com, save the date. For those of you here in person, please help us clean up by throwing away a piece of trash and bringing your chair to the back. So we still have plenty of food and drink, so everyone feel free to stick around. We'll be here doors will be open for a while longer. And yeah, feel free to stick around, have conversations, make some new friends. All right, thanks everyone for coming. See you next time.